Hi everyone, this is Jain, an aspiring data scientist and degree MSc Mathematics student at NIT Warangal. Today I would like to reflect on my recent kidney disease classification end-to-end project where I have done and implemented the Mlflow and DYC. It is an end-to-end project deployed in the AWS. And if you are curious to know more about me, this is my LinkedIn profile and this is my GitHub profile. I will give links in the description box. You can go through them. Now let's get into the video. Yes guys, I welcome you to the project. You can see image of the CT scan of the kidneys. Given the kidney CT scan image of a person, the model should predict whether it has tumor or not, means whether the person is unhealthy with a problem of cancer or not. This is a simple problem statement of the end-to-end project. Guys, now we are clear with the problem statement. Now let's get into these 13 steps where each step I will be discussed in detail and I reflected what I have learned. The first step is to create the GitHub repository setup. Go to your GitHub account and create an end-to-end kidney disease classification with your own name and come to the project page, come to the VS Code. Next we have to create the template of the entire project. How an entire project, what were the files that would present in an end-to-end project. This is the template guys. This is the template where in any end-to-end project we need all of this. We need all of these files. Import OS, these are the basic modules that we have to import, and this is a logging basic information which use the message that we wanted to show, and this is the time of the message, and this is level is the info level, basic info. These are the all the directories that we want to create on our local machine. These are the basic template guys. This is important for every end-to-end project that we are creating. These are the basic files: common, utils, logging, config, pipeline entity, params.ml, app.py. If you run this template.py file, they will automatically be created in our local directory. These are the files, and you can see the basic Python code is written. If the directory already exists, okay is that only. If it already exists, don't create. We are going through a for loop. What is the use of path? Path is a module which helps to create the path for the each directory in a local machine. It can understand whether it is a Windows machine, whether it is a Linux machine. It can understand. That is the use of path module, and it will use to, and we store in the file path, and it will split file path will split into file directory and file name, and it will check whether this directory present or not, and it will create. See, you can see the use of log file. We are saying after creating the directory, please tell us. We are telling, please tell us that this directory is created, so that we are aware what if something is not done. We know. Let us suppose if utils is already created, and it will say, okay, this file already exists, and we can understand each and every bit of code. In this way we will go to this is the use of logging. It will be very useful for debugging as well, because we are writing log file at each and every step, right? See, for here, after doing this step, give me this output so that I can know what I have done, like this. This is a basic code guys. Then we are going to see project setup and requirements installation. What is the project setup? Project setup, you can see the project setup. This is the metadata that we have to give. This is the version open readme.md. This is a basic code, and this is a repository name that I have created in the GitHub, and this is my username of the GitHub. This is a source repo where all the important files are there, and this is my author. This is the basic metadata that one should set up for an end-to-end project. Next, the requirements.txt, and we go to the requirements.txt where these are all the modules. These are all the libraries that we needed for the project: TensorFlow, Pandas, DVC, Mlflow, Notebook, NumPy, Matplotlib, Seaborn, Python box, and I will tell each and every usage of this library when we are discussing them. Okay, next one is logging. Logging. What is logging? Basically, a log is a information that we can see when an application runs. I will show you the code. I have written the log information in the constructor file of the source module. Here I have written here. These are the basic imports. OS is to interact with the system, local machine, and system. These are the basic one another. These are, and logging file. This is a basic string, guys. Basic string where the log that we can see will be in this format. It will show the time of the run, level name, whether it is info, warning, or some other module, from which module, whether the code that we run in main module, or whether we run from CNN module, whether we run from components, from which module we are running. In the message that you have seen right before, like the message. This is okay. Let's come from here, and we want to keep all these log information in a log directory. Let's say we have name. We are giving the name log directory as logs. It will create one log directory here. I have removed that after running because I have not imported that to my GitHub. It is not useful, but it is useful for when we are running for debugging, where it is happened, what happened, and whether we have everything run successfully or not, to check that. And this is a log path. In the log directory also we want a file named running logs. This running logs is the name of the file in which all the logs should present exist. Okay, if log directory is there, then don't create. That is the information, and this is the info, guys. Masa important, guys. For any project that you are doing, Masa is very important. Handlers. Why these handlers? What is handler? Handler is something which helps. See, log file path. We are saying that handler keep all the log files in this. See, logging dot file handler log file path. We are saying the log module to keep all the logs in this file path and show the output as well in the terminal. Show the log files as store all the log information in the running logs, as well as show in this file we are saying std out. We are saying that show all the logs in the terminal as well, and we are creating a basic logger object named CNN classifier logger. I think it's pretty much clear, guys. Now we are going to utils. What is there in utils? In utils, common. We are in utils. What we will write is, we will write the basic information, basic common in code that we will use for the entire project. Let us see. These are the imports. We are importing the libraries, necessary libraries from box.exceptions. We are importing box value error, importing YAML, CNN classifier logger that we have, that I have shown before, and pathlib. From pathlib we are importing path, like that. See, the return type of the below function. Okay, I am writing. I am going through one by one. See, ensure annotations. Why we are using ensure annotations? I will tell you. And why we are. See, in Python we can also create the return type of a function in this way. This is the return type of this readml file. Config box is a return type that reads what this function will do. I think each and every information is there, and if you can go through, it's a basic code, guys. You can understand what it will run. Everything is written here. Okay, now let me go to the requirements installation. Requirements.txt I have also shown you, and project workflows. In readme, see, in every end-to-end project, this pattern repeat, guys. That is the workflow. That is very, very important. Workflow is very, very important. First we will create a trial. We will do in an IPYNB in a Jupyter notebook. We will do the complete part. I will show you one by one. Let me not match anything. Okay, see, this is the workflow, guys. First we will update the config.ml. We will update the secrets.yaml if it is there, and we will update the params.ml, and this is the workflow, guys. Let's see. First we have to do data ingestion. What is data ingestion? Data ingestion is something we are gathering the required data for our project. This is data ingestion. We are injecting the data from a source. Now I kept my data in the drive, and see, first research, we are doing research. For that we are creating research.py, and first trials.ipnpy, trials.c. First data ingestion, guys. First trial, let's see in trials what is there. We are gdon is a library we use to get the information from the drive. This is a URL of my drive, and firewall, if I run this, URL is not defined. Okay, see, firewall, we are splitting the, basically we are splitting the URL, and this is the information. This is a unique ID that present for every file. That's what we are gathering from here. We are separating using forward slash, and this is the unique ID that present for every file. So we are collecting that here, and we are adding the prefix is downloads, and gdon dot prefix. See, let's see, guys. Gdon dot download prefix. This is the prefix, and this is the file URL. This is the file URL, unique ID plus this is the prefix, and let us say we are naming that as ctscan.zip, and if you run this, it will download automatically. That is what I have written, guys. It is very simple, and path is okay, nothing is here. Now let me go to data ingestion part. Yes, guys, now let us get into the project workflows. In project workflow, we have to update all these files one by one, step by step. Before updating all of these, first we have to do some research on what we have to do. First step is to create a data ingestion. First we have to fetch our data from a database, if it is database, or you can fetch data from a Kaggle API, or you can fetch data from your drive. There can be multiple sources where you can ingest your data to your repository, to your directory. As of now, I kept my data in my drive. From drive to this local directory, I have to do ingestion part, data ingestion part, and I have to keep in a separate folder. Let's do some research on how to do. See, we have to first import the operating system library. We have imported that, and I am checking where is directory present now. The directory is currently present in the research folder, but I want to be in the kidney research project. I have changed the directory using operating system change directory function. Next we have to create a data class, guys. Data class. What it is, data class? It is a entity, guys. It is a entity. What is an entity? Entity is a written type of a class. You can see here. This is a function. This is a function which has written type data ingestion at config. We can also define in this way in Python. Now I am creating my custom entity. This is, I have prepared one. I have prepared this entity. My function should return in this way. I have created that entity. Let us see. Data class, where these are the modules that I have, these are the libraries that I have imported, and this is the decorator at the rate data class, and frozen equal to true, class data engine. See, frozen equal to true, it means we are saying that we will not add anything more. We don't add any other files or any other parameters more in this class. And the data class used to access this function from other files as well. I hope this is clear. Let's go ahead, and we are importing all the constants. What are the components that are present in the constant? constant throughout the project. Let us suppose, see, from src.cnn classifier constant, where is constants? Cnn classifier, there is a component of constants where I am importing all the constants. Let us see those. This is src and constants here. Let's see what are the constants. Config, see, config file path, config.yaml and params.yaml are constant in every other. These are constants. I should import these in every other research files. You can see here. We're also importing these in these also. See, now what are the components that are present in config.yaml? Let us see those. Config.yaml, here it is. See, data ingestion part. In data ingestion part, first we are telling to create a directory artifacts in that data ingestion folder, and this is a URL, guys. This is a URL, my drive, where the data is present. Kidney is tumor images and normal images, and we are telling that keep that data in a data.zip file in data ingestion and unzip this data in data ingestion. Keep the first of all keep that data in data.zip file and unzip the data in data ingestion. See, I have done that, and here are the normal and tumor images. This is only we are returning config.yaml. You can see where is it. This is the config.yaml, and where is the constants file. See, constants here. This is we are returning path. See, you can see path. What is how much it is useful. Path library is very much useful in our complete project. This is a path, and similarly params.yaml. What are the parameters that we use in this? For the model preparation, we use augmentation, image size, batch size. These are the parameters that we use. So we have done. This is a very basic one. Now let's get into the trials. Not trials. First one, data ingestion. I have imported those. You can see this. Then I am building the configuration. How should it work? See, I am fetching those files, config file path and params file path, and I am giving to readyml file, readyml function to this. Why I am giving to readyml? These are YAML files, right? We know YAML files, and it should be read. Why I am giving to this readyml file? Let us see. What is this? It is a common code that present in common.py. Let's see where it is. It's a little bit confusing. We have to see slowly. Constants, entity, these are the components, and pipeline, entity, constants, requirement setup. This is I have done, and this is a setup, the basic one, main.py, git ignore, and these are the template. Okay, it's fine. Constants and utils. Okay, in utils it is present. Common file. See, you can see here readYAML function. What is this function is doing? It will take the path of a YAML file. In its name only it is there, and it will return as a config box type. Config box. It will return the file that we are given as the input. It will return in a config box module type. What is it? What does it mean, the config box? Okay, see, this is the basic code. It will take the file and it will change into config box data type. See what this config box. I have written that. See, let us suppose this is the dictionary, guys. This is the dictionary D1, and how you can access the key this value Python. We have to write this code d1 square bracket and quote single quote key, then you will get this Python. But if you pass this dictionary to a config box, then you can access directly easily with you only using dot operator. For easiness purpose, guys, for the complete code, if you write the square bracket every time, it will take a lot of time. For that we are using the config box. I hope you understand. Next, where is this? Why it is going always? Next, read YAML function config box. I think you also saw, I have to show something. You also saw there is a ensure annotation something. Here it is written above a function. Why it is written? I will tell you that as well. You can see here ensure. Let us suppose you can see a function I have defined here. It will take input as an integer, both x and y, and it will return its multiplication. Let's pass 2 and 3. It will give 6. But if you pass 2 comma and a string 3, what it is doing? It is concatenating 3 two times, but it should not happen, because in the when we are doing end-to-end project, and if you done by mistake error, it is also accepting. You should compulsory, you want to give, you are expecting an integer, but you are getting a string, but it is not giving the error. This may result in a error, but you cannot understand if you do so much research or debugging. If you use anything, it will be very confusing, guys. For that, we will ensure annotations. We write this function above and we will do this. Now see, if I pass this, it is giving error. It should only take integer, but in Python, if you give a string in place of integer, it is accepting, but it should not happen in our project. That's what we have done. We have ensured the annotations and it is not going. I hope you understood why we have written ensure annotations, decorator, and the what is config box type. Now let's get into the code. I hope you understood, and I kept this config.file path in config and params.underscore file path in params. Now I am creating the directories. Now I am creating, see, I have also written where is this common.py. I have also written a function which creates directory. Simple code, guys. See, it will take a list of directories, it will create os.make directories, and it will create. If it is already there, then don't create. And we are saying, see how much logging is important, very much important. See, after doing this, tell me that okay, this has done. Then you will be very confident. Okay, this part everything is going successfully. You will be very confident on your project, right? Then okay, now it is done. Now you can see here I am creating, what is this root artifacts. You can see this in the config.yaml file. Where is this config.yaml file? This is the config.yaml roots artifacts. This is, see, I am telling to create the artifacts folder here. This is the artifacts folder. This is the artifacts file config.yaml, and this is the data ingestion.yaml. See, you can see here it will create the directory like this as it is done, artifacts. Now I am creating a function which can get the data ingestion config which has the return type as this, the entity as I have defined. This is my custom entity that I have defined for this function only. See, config equal to self.config.data ingestion. What I am telling in data ingestion, take the data and keep in this config. Now create the root directory. What is this root directory? This root directory is the, you can see here, root directory is the data ingestion. In artifacts folder, please create me one folder which is known as data ingestion. In the data ingestion, let's see here, in the data ingestion, and keep that in a config. See, we are giving a variable name config and create that config dot root underscore for this data. Keep this in this config dot underscore root. Keep that in the data ingestion. Now data ingestion config, we are creating the object of this function. See, this is object of this class object of this class, in which we are assigning the value. See, we have defined something and we are assigning. For root directory, what I have to add, I have to give the path. For source URL, what I have to do? I have to give the string. For local directory, for what I have to give the path. That's what I have done. I have assigned each and everything. Root directory, config dot root underscore directory. What is this root underscore? This is data ingestion file. This is data ingestion file here. And this source URL. I think you already saw before. That is the drive where I kept my data. And you can see here, and local file data. This is a basic. Now that is a zip file that is present in my drive. Now we have to unzip the drive. We are giving each and everything. What we have created some files, some variables, and we are giving values for those variables. Now return this data ingestion config. Return this. Please return me. And now importing some basic libraries you are importing. Now you are creating the actual class of data ingestion. What should exactly we have the foundation. We have the foundations ready, but now we have to create the building. How you will create? Let us see. You are returning this data ingestion. We are calling data ingestion config. What is this? This is data ingestion config class. We are assigning to this config, and this config has this complete data. Now we have to download the data from the URL. Yes, of course. This is a dataset URL where we have source underscore URL. You can see source underscore URL. This is the source underscore URL. In that my URL is present. That's why I am calling here config. Why I am telling? Because it is present in config. Here you can see here config. It is present in this config variable. In that config variable source underscore URL. And why I am using self? Because it is a class. That's why I am using self. And now I have to zip file. This is data will be stored in local data. This is in zip file. Now I am making the directory data ingestion, where if it is already there, then don't do and create the data. This is a simple code which will download the data from the drive, and it will unzip and it will keep here in data ingestion. That's what, guys. This is a simple code. Now we are calling one by one. First my configuration manager, next get data ingestion config, where I will give the values for root directory, everything. And next I am calling my data ingestion actual function. Next I am downloading the file. Next I am extracting the zip file. That's what. This is a simple data ingestion code. Now we have done the research, and I have run the code, and it works successfully. But after running again, you can see that it is downloading also. But I have stopped because it is 939 MB, and again I have given some 200 images, and it will be 59 MB. This is another story, guys, but it worked well. Now I have done the research. Now go to the readme. What is the project workflow? You can see here workflow. Here first we have to update the config.ml. Yes, you have done that. Config.ml, you have updated that. Yes, you have done that for the data ingestion part. Yes. Now go to we don't have this file params.ml. Yes, you have also done this. You can see params.ml. You have also done this. Next let's go to where is this? Next you have to update the entity. See, what is entity? That entity we have defined, right? That is only the entity. See, I am going to config entity. See, this is only I have copied from there, and I have just pasted it here. I copied from there and I have pasted it here. Just next I have to do. Next what I have to update? I have to update the configuration manager. Where it will present? It will present in config. See, you can see, guys, everything is structured. It's the understanding. It is a complete understanding that one should have. See, this is config. These are the import that I am modules that I am importing, and see you can also see this is a configuration manager which I have defined before. You can see here. See, this is only I have copied there. See, this only I have copied there. I have simply copied this one there. These are the I also copied this, and next I am copying this part. Simple, this complete code I am copying here. This is a complete code I am copying here. Next get training data, complete code. So this is the This is the data ingestion part. For data ingestion part, this is the configuration manager that I have defined. This is the for training part, this is model part, this is evaluation part. See, again we have to do like this one. We have to do research, and we have to keep the components where they should present, and we have to run the main.py file. Simple, guys. See, next what is present here. Next what we have to update, we have to update the pipeline, I think. No, we have to update the components part. Where is component? See, this is the components. Now I have created data underscore ingestion.py file. See, I just copied that class data ingestion. See, just copy it from there. You can see, right? It is very useful and very clear, right? What I have done, what one should do. If you go to line by line code, you will understand, guys. Or if you have the tools, I think I should not say. It is now it is trending. All the tools are trending. Now you can see I have to update my pipeline. See, I will go to my pipeline part. See, here is my pipeline. I have created one file, stage 1 data ingestion.py. Simply I will copy the code from there. See, I will create the data. Everything is for our understanding only we are writing. See, this is a class I am creating, data ingestion training pipeline. This is a constructor, and we are defining the main function, where this is the one by one, step by step we are calling. First configuration manager, next get data ingestion. We have defined in that way, and we have to call in that way only. It is obvious, right? This is a file part. Next, now I have copied this also from here itself. Where is the stage 1? This is, see, here itself. This is the code I have copied there. We have to first research on the complete component. Let us say whether it is ingestion, whether it is preparing the model, whether it is training, whether it is evaluation. We have to do the research. Then we have to update each and every component, like and we have to follow the workflow as it is mentioned in the readme. It's very simple, guys. Next, like that, the workflow part is, I hope you understood the workflow, how one should do the workflow. This is the I am giving my understanding here. That is what I have. That's my intention. You can go through this code. I think I have gone through the code as well. Yes, guys, in this workflow part I would like to explain also the training part, how it was done, how the model is created, which model I have used VGG16 model, which is a pre-trained model, and I have just changed the last part, or we can say there are 5 dense layers of VG16, and there is a one fully connected layer. In that fully connected layer I have removed the all the neurons that are extra neurons, and I kept only 2 neurons for the one for tumor, one for normal. I hope you understood. Now let's go to the training part. First we have to do research. For research, let's go to the what I have done here. Let's go to the research part. Again the same code. Again I just redirected to my project. Now again I have created the entity. See, we can see the entity. First, for this entity, why I have done this entity like this? Because in my params in my config.ml, you can see training, the root directory. Already this artifacts is there. I have created the artifacts in the data ingestion part itself, and now the root directory is training. In that artifacts, now before the root directory is data ingestion. As you can see, we have stored the data where now we have to store our model here. Training, whether training model. Next, train model path. After model is trained, then we are giving its name as model.h5. I don't know why Sar given this h5 extension, but this is a model name Sar has given, and this is the code. This is not useful actually. This is not useful code, not for this project. That code. Okay, let's get into the project now. This is model.h5. Now, see root directory. This is the path, right, where training is. We are giving here the training is going. Now here what is going? Model.h5 is going. Updated model path. We are also defining this updated model path, training path, later stages, and training path, training data. Where is training data? That is present in data ingestion. params epochs. Where is this params? See, we are also giving the name params because they are parameters. You can see here params.ml file. Where is this? Let's go here, params.ml file. Here this is the params.ml, and what are the components that I want? Epochs, I want learning rate for the model. Yes, I hope you understood. This data, let me remove it. I will save it and I will remove it because now we don't want that. Now where is this shit? Research file. In the research we are going to model training. Model training, you can see model training. Now params epoch, we want the number of epochs, and augmentation, this is a boolean type, bool, whether it is true or false. Next, image size, list, it is a list, you can see 224. VG16 takes 224 and 3. What is 3? RGB image, red, blue, green. I hope you know that. It's a basic. If you gone through the deep learning, I hope you will understand. And these are the directories as of, see, you can see from constants I am putting all. From common, what are the common functions that I use here? Readml and create directories itself. I hope, before I told you, as I told you before. Again same code. I am taking. Now I am doing the training, get training config. See, and this is my custom entity, and this is the entity, custom entity for this function. This function should return those. See, training is equals to training self dot config dot training. In this config we have all the files, we have all the directories, means config file path, we have those. Next we are calling this prepare base model, where it's present. We are assigning those values. Just see, this is the training path. See, root directory, training model path, where each and everything is present. We are just assigning those params only. Params is equal to self.params. We are completely assigning all the params here. And training data, is os.path. This is the unzipped data, where it is present here. Training path, this is the name of the data. Training data, where is the data ingestion, unzipped dr, where it will be named in this way. And what is training data config? We are creating an object of this class, object of the above class. We are just for root directory. Where is the root directory path? See how much path library is very important, is useful. Training dot root underscore dr for training. This is a training. Root directory is where. What is the root directory for training? Let us see here. Root directory for training. See, this is training folder itself. Root directory for training. And why again here training? Because we have assigned this self.config.training as training. That's why we are, as it is a class. Now you can see we are just assigning each and every value to this parameters. We are assigning the every parameter to their respective ones. That's what, and we are returning those. We have done the same code in the before data ingestion as well. Similar code. We have to assign. We should know the modular coding, the object oriented coding. I hope you know those. Know that. Now, see. Now our pipeline. Now our component is. Now we are creating the component, training component. What it should do? We are taking the input as this. This is the input. Training config. That one is the input, and each and every parameter is coming into this class, and we are just wanted to prepare the from the TensorFlow Keras models, load this model, updated base model path, from where we have to get the model from Keras model, load model, which model, VGG model we have taken. And these are the general. I think this is the train valid generator. For if, see, let us suppose this is augmentation, guys. What the code is all about augmentation. What is augmentation? Let us suppose if there may be instances or circumstances where you have less data. you have only 200 images, but you are getting very less accuracy with that. It's obvious, right? But you have, in the augmentation, what we will do is we take that only 200 images and we create more images by flipping those, by rotating those, something we do some parameters, and we will see. I think all the parameters of, see, rotation equal to 40, or horizontal flip equal to true, width shift equal to range. These are the basic ones. These are the basic parameters that we go, and it will shift and it will create the data. That's what this complete code is all about. Training, using the training image that I have, please create me other images by flipping those, by horizontal flip those, by width shift, by changing their width, by changing their height. Please create me other images of the same type. That's what we have done here. You can go through this code. And otherwise, if we give, but I have the enough data, I kept the augmentation as false, and we are giving the static method. See, when you, what is static method? This method will not change for the entire code, and you can access this method from other files as well. That's the static method we use, and we will not give any other parameters after defining the static method as well. See, the path of the model.path, and now save the, we are saving the model now. We have created the model and we are saving the model. Now we are training the model here. We are training the model, just we are training the model, and we are calling one by one. And after doing this research, after completing this, you can see this training is done, and I got the valid accuracy as 90%. I don't know, for 200 images itself, I think, not for 200 images, for 5,000 images of the tumor and 2,000 images of the 5,000 images normal and 2,000 images of the tumor, I am getting 90% accurate. You can see this. That's how the VG16 is powerful. I am just trained only the 2 neurons part itself, fully connected layer, but it is giving 90% because imagine it, the VG16 model is trained on the ImageNet dataset, which is a combination of so many images, and it has very good knowledge, so it can able to perform like this. I hope this clear, and we are just keeping, I hope you understood. Now I will go through it again. See, first we have to update the config.ml. I hope it is already written. You can see already written, and this way I am updating this. Prepare this one. Now training, I am doing the training. I have prepared the model before. I have not explained this part. You can go through it. I am just going to tell again. I am just going to repeating for you. And next, this param components. Next, params also I have showed. I have not, there are the augmentation or epochs, learning, those are the parameters, and the entity. Let's go to the entity part. Where is the entity? This is the entity. See, just the entity that I have created for the class. This is my custom entity. We have to write all the entities here. That's what this entity config is all about. We have to properly arrange the data. That's what, guys. Next, configuration manager. Where is my configuration manager? Configuration manager. Now see, this is the data ingestion part. Before I showed you, this is the training data. See, you can see this is a prepare model, this is a training. So functions, I am just keeping those functions here, I am just keeping this function there. That's it. And now I will keep this in my component. Now I will, this is complete code in my components part, and this I will give in my pipeline. You can see here, pipeline model training. See, I am just keep a staging training, and I created a class named as model training pipeline, and this is the code. I just copied from there and I pasted it here, and this is a main file where logger. See how much logging is useful. See, after starting this project, tell me this stage is started, and after completing this stage, please give me this message for my purpose itself, for the clarity, for the confidence that everything is going the complete. When you are running the entire code, the complete end-to-end project, then you should know where it is up to which part the code has gone, up to which part the model has done training, whether it is training done, whether the evaluation is done. For that only, whether we got any errors, see how much it is useful. I hope you understood the workflows of the project. Now the entire pipeline is came into the main file. See, data ingestion part. I am directly calling this object data ingestion pipeline, training pipeline. Just if I call this, then complete data ingestion will be done. Then if I call this, if I call the main.py, then my complete project will be done. But what is the requirement of DVC then? The requirement of DVC is, if my complete project is done, then if you call, now my data is collected from my drive, it is downloaded, and it is data ingestion part is completely done, git ignore file created, my model is also prepared based on the data, and my model is prepared by my model is prepared. Now training day, after training my model is also prepared. After training, this is my model.h file. But you don't want to download again this data, and you don't want to prepare this model. Means these two steps you should want to skip. You want to skip data ingestion part and preparing the model part. But if you call the main.py, it will run from the start. Even though the data is present here, it will run from the start. That is the drawback of this approach. Then the DVC comes to track the entire project. Where is this DVC? Let me go here and see. I'm just writing. These are dependencies. This is see. These are all the stages, guys. In the stages, everything is mentioned. You can see the indentation. Indentation is very important. In the stages, everything is mentioned. Let's go to the first part, data ingestion. In data ingestion, what is my command? It should do Python source in that CNN class variable. Let me show you. When I am telling, see, you can see here, source module, go to CNN classifier. See, this is a CNN classifier. You can see my cursor, and this is my pipeline. Go to pipeline. This is components part, config part. Just let me close all of them and see, this is my pipeline. Go to pipeline and data ingestion and run this file. For running this, that file is needed, right? So that is one of the dependency for this. And for running, for running this file, what are the other files that are requirement, that are dependent on this file? Config.ml. This file is dependent for this file. See, you can see when I can go to here. I can go here and you can see I am running this pipeline, right? Where is the pipeline? Here. This is the pipeline. Config.ml configuration. See, configuration. I have to go to the configuration. Where is the configuration? Is there? Is configuration. In this configuration, you can see my entity, everything. See the config file path. Everything is there. These are the dependent config file path. These are important. That's why that is a dependency, right? That's why I mentioned there. I hope you understood why I have written there dependency. I hope you understood. Now what is the output of this? What is the output of this? It will create the artifacts folder. It will create the artifacts folder. In that folder, it will create data ingestion folder. In that, it will unzip this. This is my output. Here normal and tumor images will be there. This is my output. That is I have written. This is very simple code, guys, if you understand. Now let's get into the prepare base model part. In this part, the model should go to prepare base model. Where it is there? You can go at the pipeline, prepare base model here. It should go here. Yes, right? Then for that file, you can see for that file is needed to run that, and config.ml obvious. See, that is the, see, when we are preparing the model, we want the image size, right? For VGG16 we know 224 3. This is the list we have to give, and include top, whether we want to include top. Yes, when we are training, we don't want to include the the five dense layers that are present in the VGG16. We don't want to train that. It is already trained on the ImageNet data set. We just wanted to train the bottom layer, which is a small CNN layer that we have created. Small fully connected layer, ANN layer, which has two neurons that we want to train. That's why here include topic called false. You can see in the params.ml files. You can see, guys, I written false. Why I have written? I don't want to train that. This is the image size. That's what is the dependency? Simple. See what are the params here, what are the dependencies here, and what is the output. Like that I have written those for these two. That is the use of DVC. Now what is the I have not till the use of DVC. If you run after running complete project once, if you run again python main.py, it will start from the cache. It will download the data, it will prepare the model, it will train that. But you want directly from training, then what you have to do? You have to run dvc repro, the command dvc repro. You can see here in my readme.ml. You can see, I think I have mentioned. See, we have to initialize the dvc like git init. This is data version control. DVC means it is very similar to git. It is also a data version control system. See, DVC repro means it will run the repository. It will also give the entire diagram, pipeline diagram. It is a beautiful tool that is created, guys. ML. I think you understood. It's Mlflow. It's for production grade. Track all of your experiments, logging and tagging your model. DVC, it's very little weight for POC only. Little weight experiments tracker. It can perform creating pipeline. See, you can see this is the pipeline that is created. At the end of the day, we have created that pipeline. We have created DVC.ml. Here, this is our entire pipeline here. You can see, guys, how beautiful it is. This is the entire end-to-end project. Now we want the front end. For the front end, we have to develop the app.py. Now you should know the Flask here. I have downloaded, I have imported all the libraries regarding to the Flask, and this is the decorator app.root. This is the method get. You should know the Flask, guys, basic Flask. These are the, if you learn the Flask, you can understand this. These are the, for training I have created the web part. Means there will be some portal for training, portal for prediction, portal for training. If you /u train, and at the end of the day I have created the client app with the port 8080, and then I have deployed in the AWS. If you want to know how deployment is done, see, deployment is all about the I have not understood the deployment where he directly went through the AWS and I have done something, and he run the commands. First, this is my first project where I have deployed, so I have not get the complete clarity how the deployment is done. But you can see the instructions, guys. Here, see the EC2 instance. It is a virtual machine. ECR, elastic container registry, where you save the Docker image as the AWS. Description about the deployment. Build Docker image of the source code. Push your Docker image to ECR. Launch. See, you can see my Docker file where the CI/CD pipeline, continuous evaluation, continuous deployment is done. We have to run the basic commands. The project is done, guys. Now, how the CI/CD pipeline is created and how it is deployed into the AWS cloud. That is what you have to learn at the end of the day. I hope you understood. This is my understanding of the project. Thank you, everyone.